Hi everyone, we're going to look at your heating curve and another animation from your footprint science. Below here you have your solid state and the particles are actually vibrating in fixed position. You can see that. Moreover, the force of attraction is very great here, right? So the particles are, they have a regular pattern. Now we move to the liquid state. Look at your liquid states on your graph. So you can find that particle here showing the liquid. And on your left, you see the particles. They slide past each other. Now the movement is randomly and slow. That's a movement with strong forces of attraction, but not as strong as those in solid particles. That's one thing you need to note. Yeah, that's why the particles are still closer to each other. Okay. The third case or the third state is your gas. Look at your gas on your graph. You can find it right up there. And behold, the particles, they move randomly and fast. They move randomly and fast. Secondly, they have weak forces of attraction. Right? The particles are they are separated further apart. So some of the things you need to note. Now, coming back to your liquids, and we will have to, apply heat there to, to monitor the changes of state. So if we apply heat there, then we are applying actually melting, okay? We are trying to melt that solid state. So if we melt it, look at it, the temperature is increasing. Now, at one point, the temperature stops increasing, that's a plateau, and that's where melting is taking place, and it becomes a liquid state. That's it. It becomes a liquid state. So look at the particles now. After applying heat, so melting has taken place. And you can write this melting equation. It's an equilibrium equation. So this process is melting. Now, I'll rather put it on top. Good. So that's your melting. And the equation, assuming that substance Y, so you will have Y solids with your equilibrium forming what? Y liquid, right? So these are some of the key questions you might find. Y liquid. Now, moreover, we now continue to heat our liquid particles, and that's boiling taking place. So what happens when the particles have been heated further again? You see boiling takes place and you have your gas. You have your gas particles or your gas states, right? And at that point, so boiling has taken place. So here, this is boiling, telling you that the heat added did not actually increase the temperature, but rather what went further to break down the forces of attraction between those liquid particles to form your gas particles. And the equation there would be Y liquid forms your Y gas. That's it. That's a simple heating curve. I think with this, your heating curve is complete. Yeah. Now, the next step we should talk about is what the cooling curve. The cooling curve will just start from your gas right down. So I'm not going to draw it. I'll use same uh, diagram, but explaining coming downwards, right? Telling you that that will be your cooling curve. So thank you for watching. And if you have any comment, please just keep your comments or your questions or your doubts in the comment section. So, and wait briefly for your cooling curve using this same uh, diagram of the heating curve.